Hey, welcome to this session on least common multiple. Today we're going to talk about multiples and then we'll try to find the LCM of two or more numbers. What are multiples? Now, if you know the multiplication tables, then you pretty much know what multiples are. So let's list the multiples of 5, 5, 10, 15, 20, 25. This is what we have in our multiplication tables. So these are actually the multiples of 5. Similarly, for 12, we have 12, 24, 36. So you're multiplying 12 by 1, 2, 3, 4, so on to get the multiples of 12. So you are good to go if you know your multiplication tables very well. Okay. Let's look at what factors versus multiples are. Now, when I say 5 times 2 is 10, then 5 and 2 are actually the factors of 10. Looking at the other way around, we can also say 10 is actually a multiple of 5 and 2. So factors means we are actually multiplying them to get a number. And here a multiple is a product of its factors. And both the two or more factors will be able to divide the number exactly. Like 10 is divisible by both 5 and 2 exactly. So this is how you differentiate between the two. Now let's see how we can understand about least common multiple and find it. What is a common multiple first of all? What do you think is a common multiple? When we list the multiples of two or more numbers, we have to find something in common between them. And that is actually the common multiple. Now here we have listed the multiples of 2 and 6. Now we all know our 2 table and we know the 6 table. What do you think is common between these multiples? We see 1, 2 and 3 numbers are common amongst those multiples that are listed here. So the common multiples of 2 and 6 are 6, 12 and 18. Now we know common multiple. What is the least common multiple? Some people like to call this as the lowest common multiple. What is the lowest? It's obviously the smallest of the common multiples because two numbers, as we saw, can have more than one multiple in common. Now we are trying to find the smallest of those common multiples. For some reason, 0 is always excluded from common multiples, so please keep this in mind. Now, why do we need the LCM or the least common multiple? Let's see. Now, if we have a certain event that is repeating itself, we want to know when will it happen again. For example, if we look at 3 bells in a church that are ringing at different times, maybe we want to find out when will they ring again together. That's when we would be using the LCM. Now, another place where we really need LCM is when we are dealing with fractions and we want to find a common denominator for fractions. Okay? Let's look at a live example so we can understand about LCM better. We have 3 strings of lights here. The first one lights up every 1 second. The second one lights up every 2 seconds. Third one lights up every 3 seconds. Now the question is, when will all 3 of them light up at the same time for the first time? Now I've listed the time in seconds, 1 through 6 seconds here. And I've also given the strings of lights. Let's see, the first one lights up every second. So I have a check mark against every second here. The second one lights up at 2 seconds. So that's what I've shown here. And then again at 4 seconds and then at 6 seconds because it does it every 2 seconds. So it's a multiple of 2. Now the third one has to be a multiple of 3. So it starts at 3 seconds and it also next time it comes on at 6 seconds. Now what do you think by looking at this table? Can we figure out when will all the 3 strings light up together? It is at 6 seconds. So this is how you would try to find the LCM. Now let's do an example by listing the multiples. We'll do the same example and with numbers now. So I've listed 1 second, For 1 second, I've listed all the multiples. For 2 seconds, I've listed multiples. 3 again, I've all the multiples here. Now, what are the common values here? We have 6 and 12. But what is the least common multiple amongst these? It is 6. So the LCM of 1, 2 and 3 is 6. So by listing the multiples of numbers, you can figure out what is the first one or the smallest or the least one which is in common between all the given numbers, and that becomes your LCM. Now another trick to learn is if we have two numbers where one is a multiple of another. Now here 8 is a multiple of 2. We know that 4 times 2 is 8. So I say the LCM is the bigger of the two numbers, which is equal to 8. How is this correct? Let's see. Now we list the multiples of 4 and then we list the multiples of 8. And what do you think is they have in common? It's the number 8 is the common multiple. But it also happens to be the first value that is common between 4 and 8. So obviously the LCM is equal to 8. Now we can do the same thing with 10 and 20, where 20 is a multiple of 10. So I'm going to say the LCM of 10 and 20 is 20. If you list the multiples of 10 and 20, you'll see again that 20 is the first multiple that is common between 10 and 20. So this is a small trick that you can use to do your LCM when one number is a multiple of another. Let's look at prime factorization by using the factor tree method. Here I have 25 as a product of the prime numbers 5 and 5, 30 as a product of 2 and 15, but I know 15 is further broken down into 3 times 5. So we have prime factorization as 5 times 5 or 25. For 30, it is 2 times 3 times 5. Now, something to keep in mind is a multiple is divisible by its factors. So, the LCM, which is the least common multiple, is obviously divisible by both 25 and 30. So, the LCM and 25 and 30, how do I use these prime factors to get that? First of all, whatever LCM I get must be divisible by 25. So, obviously, it has to have a 5 and 5 in it. So I'm going to put those two 5s in there. Now when it comes to 30, we need a 2, a 3 and a 5. So I'm going to put the 2 and 3 because I definitely need those two numbers. But when it comes to 5, I already have two 5s here. So I already have a 5 in here. And because I want the least of the common multiples, I am not going to include another 5 again. I'm going to use the existing one. So for 25, we have these two 5s. And for 30, we have these 2, 3 and 5. So now this is the LCM of 25 and 30. So if you look at it, it is 5 times 2 is 10. 10 times 3 is 30. 30 times 5 is 150. Now 150, if you look at it, is the first number that is divisible by both 25 and 30. So it is the LCM of those two numbers. Let's look at another example. We have 20 is 2 times 2 times 5. 24 is 2 times 2 times 2 times 3. So this is prime factorization. Now remember once again, a multiple is divisible by its factors, so the LCM must be divisible by both 20 and 24. So LCM of 20 and 24, let's go over this. Now we need a 2 and 5. Okay, I'm going to put those three numbers. Now for 24, I need 3 2's. I already have 2 2's. I can use them. But for the third 2 and the 3, I'm going to include them. So these 2 2's and 3 are divisible by 24. And these 2's and 5 are divisible by 20. So obviously this number is divisible by both 20 and 24. Now when you see this number is going to be 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. 40 times 3 is 120. So the LCM is 120 in this case. Let's look at the last method called the division, or some people also call it as the ladder method. This is probably useful the most when you have like 3 to 4 numbers that for which you need to find the LCM. Now to get started, I want to divide these by a common factor such that at least the number should divide at least 2 of these given numbers. But now I know 2 can divide all these 3 numbers, so I'm going to divide them by 2. I get 2 times 2 is 4, 2 times 6 is 12, and 2 times 9 is 18. Now when it comes to these 3 numbers, 2 can divide 2 and 6, but it cannot divide 9. So what am I going to do? I will still divide them by 2. I get 2 times 1 is 2. 2 times 3 is 6. But this number that is not divisible, I'm just going to bring it down as is. Now these 2 numbers are divisible by 3. So I divide them and I end up with 1, 1 and 3. Now there are no more common factors because we already know 3 is a prime number. So I stop the division right here, and then the LCM is the product of these numbers and these numbers. Okay. Now I'm going to ignore the 2 ones and I'm going to say LCM of 4, 12 and 18 is 2 times 2 times 3 times 3, which is equal to 36. So the best way to remember all these different methods of finding LCM is by practicing it more and more. Before we leave, let's do a last short quiz. What is the LCM of 9, 18 and 36? Can you tell me? Now, one thing to notice is 18 is a multiple of 9 because we know 9 times 2 is 18. So we have 18 is a multiple of 9. How do we get 36 from 18? 18 times 2 is 36. So 36 is also a multiple of 18. So 36 is a multiple of 18. 18 is a multiple of 9. And 36 is a multiple of 9. So what did we say in such cases? The larger of the 3 numbers is actually the LCM of those 3 numbers. So it is equal to 36. Keep practicing more and more problems to get the LCM, because we'll be doing in the next session, we'll be talking about adding fractions and we'll use LCM a lot more in there. Hope you enjoyed this session. We'll catch up with you in the next session. Thank you for watching. Bye-bye.